In this video, I'll be solving number 3 in the free response question set that the College Board put in the AP Pre-Calc course description. Okay, so this is a no calculator question. Let's see what it says. The blades of an electric fan rotate in a clockwise direction and complete 5 rotations every second. Point B is on the tip of one of the fan blades and is located directly above the center of the fan at time t is 0 seconds. So it marks point B over there, as indicated in the figure. Point B is 6 inches from the center of the fan. The center of the fan is 20 inches above a level table on which the fan sits. As the fan blades rotate at a constant speed, the distance B and the surface of the table, the distance between B and the surface of the table periodically decreases and increases. Sinusoidal function h models the distance between B and the surface of the table in inches as a function of time t in seconds. The graph of h and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, P are labeled on the graph, no scale is indicated, and no axes are presented. Determine possible coordinates t, h of t for the 5 points F, G, J, K, and P. Okay, so actually, in my opinion, this makes the grading harder in this for whoever's going to be grading this problem because there's no set time t is 0. You can set it anywhere. So they would have to consider there are lots of solutions that are valid, basically. So they made the grading harder for themselves. But anyway, let's see what's happening. So we want to mark coordinates for these points. And this curve is basically the height of this point as it's moving in a circle when this fan is rotating, right? That's what's happening. So we are told that the center is 20 inches above a level table. So if this guy is the table, this horizontal line, we know that over here is 20 inches. All right? And then from the center to point B, this is the sentence over here, that is 6 inches. Okay? So we know that since this is circular, when B rotates and is down here, what would that height be? Because it's a circle, this is a radius of 6. Here is 20, so it'll be 20 minus 6, which is 14 inches, right? And so that might be key. Okay, so we can actually mark the y coordinates of these points already. So let me put like a table. So this F, G, J, K, and P. Those are our 5 points, right? We want some like T and some H of T. Okay? That's what we want, right? So we know that at this point, it's at the highest height. So that would be when B is right where they drew it. How high is that? That's 20 plus 6, so it's 26. We can mark that as the y coordinate. All right? Now, G is at the average value. Or what does it say? It's it said it's some dashed midline. Okay, so that's the average value. So that would be when it's here at the center, right? Because it's going in a circle, so it's going to hit the center twice, as it does over here, right? Oh, by the way, we can even mark P already because it's back at the top again as it rotates, right? So at P, it will be, once again, 26. As we said, G and K, it's when it's going to be at the center. What's the height? That would be 20. J is at the lowest point, which is down here. So that, we said, was 14 inches. So we got all the y coordinates already. Okay? Now what about the horizontal coordinates, or the t, or the x, whatever you want to call it, okay? So this is where it's arbitrary. As long as you get the period right, then any answer is correct. So if we make it easy for ourselves and mark t equals 0 at this point, okay, we know that at this point it completes 1 full cycle. So how long does it take for it to complete 1 cycle? Well, it says it completes 5 rotations every second, which means it's 1 rotation in 1/5 of a second. All right? So what's 1/5 of a second? That's 0.2. Okay? And intuitively, if this is the period, this would be half the period, right? Which is 0.1. And these are just the midway points in between. So this would be 0.05 and this is 0.15, purely because this is a sinusoid. We can easily do it like that. Okay, and that's how I would answer part A. Once again, if you shift your t's by any value, that's a correct answer also. So once again, they just made the grading harder for themselves. All right, function h can be written in the form h of t is a sine of b of t plus c plus d. Find values of constants a, b, c, and d. Okay, so let's do the easy part first. This is sinusoid, or sine and cosine are very similar. Hopefully you learned that. Cosine and sine are just shifted by 90 degrees, and we typically say that cosine is earlier than sine, at least in the industry that I'm in. And yeah, in the courses that I've taken, they always said cosine is earlier than sine. So anyway, we can get the amplitude and the vertical shift first. Those are always easier. Okay, so how much was it shifted up? It is shifted up by the average value, which is what? It's 20, right? We can even go back to the picture. The average value is 20, so that's what d will be because it's shifted up by that much. How about the amplitude? That's the swing. How much is it swinging from the average value? That would be a height of 6, right? So the amplitude, A, is 6. Okay, so now let's do the tougher part, the B and C. So C is how much is horizontally shifted, and B is the period. So what is the period? Remember, let me go up here. If we have like sine of omega t, the period, capital T, is 2 pi over omega. Okay, so we know that we want the period to be 0.2, right? Because that's the amount of time it takes to repeat again. So we want 0.2 to be 2 pi over omega, which is, in our case, it's b. So I'm going to write b up here. Okay, so that means b is equal to 2 pi over 0.2, which is the same thing as 2 pi over what's 0.2, 1/5, which is 10 pi. Okay, so our b is 10 pi. That's our period. Okay, now how about C? What would that be? Well, since we set t as 0 here, it looks more like a cosine. Okay, but so if it were sine, it starts from the average value and then goes up, right? So it would be this point over here. So how much did it get shifted by? So this point, how much did this point get shifted by with respect to t equals 0? So we can even go from here to here. It's the same points, right? So it's got shifted by 0.05 to the left. So our C would be 0.05, as simple as that. Okay. Refer to the graph of H in part A. The t-coordinate of K is T1, and the t-coordinate of P is T2. So this is T1, this is T2. Okay? On the interval T1 to T2, which the following is true about H? Is H positive or is it negative? Clearly it's positive, right? By our model, everything's positive, so we can eliminate C and D. Is it increasing or is it decreasing? Clearly from T1 to T2, it's increasing, right? So the answer is A. Very easy. Describe how the rate of change of H is changing on the interval T1 to T2. This is related to concavity, and you can even tell by this graph that it's increasing at a decreasing rate because it's slowing down and it plateaus and finds its max at P. Okay, and the correct answer would be to use concavity. So we can say that H is increasing at a decreasing rate because h is concave down. Right, it's concave down at this point. And we can even specify on the interval t1 to t2. You should say that because it's only true for there. Okay, and that's how we solve number 3 in this problem set. Hopefully this was helpful. Please like this video if you did find it helpful, and please subscribe also if you haven't already to support the channel. Thanks, and I'll see you in the next video. Bye.